All right. Hello, everyone. So who was there at the previous panel? I have some lifers. That's good. Okay. Now, just because we're gonna, this is a good topic to continue on the previous one. By the way, for the ones who weren't there, my name is Charles Bovet. I'm the Chief Product Officer at Bone Structure. And today we have on the panel Brendan Kelly, who's the architect for this masterpiece. And we also have Alex from the Bone Structure team. He's our construction manager, assembly specialist. So he's the one who is on the job site working with the local teams to make sure that everything goes as smooth as possible. What we want to focus on in this last panel is the mechanical systems, the MEP, how everything gets put together. When we do these events, we leave the walls open where we can see what we find is the nicest part, the shell, right? So the shell is a good first step in making the house comfortable, making it energy efficient. But that's just the first part. That's what we call, we have the bones, we have the insulation, but then it's the lungs and the nervous system that we add. So Brendan and then Alex, maybe you can talk a little bit about how you designed and what were the main challenges for the mechanical system in this specific project.
Thank you, Charles. Gary Larson, who owns the Furnace Works, he's a design build guy from this part of the world, and he's going to come rolling through here in a second, and we're going to slot him into that chair.
We'll keep the hard questions.
And that's right. So I want to save some of the mechanical and HVAC ducting. For example, when you see the ductwork, it's all lined up here. Many of these things happened in the bone three-dimensional model that we spent many hours looking at, going through every single major system, just as you design a boat or a significant commercial building. It rarely happens on a house this size where you can have a structural system in 3D where you're testing mechanical, electrical, and plumbing systems. That said, mechanical, electrical, and plumbing contractors don't typically see this kind of system, and they're not really like, well, do I really have that space? And they just would prefer to have a ductwork or solid walls to run conduit through, and they like their subs or their employees to kind of have a drill and run electrical conduit through. So obviously none of that is possible on a system like this. This is the interior of the building. The sheetrock goes right on this hat channel, or the wood. Everything that's enclosed that's in the polystyrene gets a thermal sheetrock layer for the thermal barrier, and then you can put wood and stone and tile and all the things that would typically happen in a house. But all of the electrical runs go through these pre-drilled holes, and they all zoom through these parts. And so getting the slab designed and making sure, Alex, one of the best parts about having Alex here was strategically putting plumbing and electrical services in the ground so that when they do come out of the ground, and we have a lot of windows here, and there's ceilings are down, and there's just not a lot of room to play for later decisions. So a lot of conduits and a lot of plumbing lines went into the slab, even as there were many opportunities for late changes or alternative designs in the ceiling. And you're seeing one of them here. These are straight duct runs for a high-pressure HVAC system that will service the supply and return of conditioned air in this room and all through the house. And there's another unit for the space on the south side of the building.
And just expanding on what Charles was saying, when we get the building permit, not only does site work start, but at that point we're building this house in the 3D on the computer, down to every single hole that you see here. is modeled on this computer system, and to be able to engage with your subcontractors and get them in front of a screen. I was able to actually go through with Gary, and he told me I need 4 inline runs this entire length of the house. I go call back to our guys who are modeling the house on the computers, and we're moving holes around. So all of our beams come with a certain amount of holes, but I was actually able to say, hey, I need this hole to line up with this hole between this beam all the way through to here. Dot, dot, dot. A few minutes later, we've laid out the beams to already work and be sent out and manufactured one time with the holes exactly where they need to be. Being able to do that can just save so many headaches and things that are going to slow you down on site. Gary can order everything he needs and the dimensions that he needs ahead of time. So every house we can be doing this for plumbing. We have a duplex that's going to be built in Laguna Beach later this summer, and doing similar things with the plumbing. I have my plumbers draw out their dream layout for every pipe in that house, and we can figure out exactly what needs to be where we might need to make an accommodation. So, like Brendan was saying, this is stuff that's happening when you're building airports and hospitals normally, but not really in a residential setting. So the ability to streamline and make the process go smooth all the way from the moment you get the building permit is really an opportunity for a lot of efficiency.
So how would that be done in a traditional construction? Because that's where the biggest difference is. What we hear, especially in residential applications compared to commercial, in residential applications, the subcontractor, the mechanical sub, comes in that Monday morning, and then...
Oh, there he is, Gary.
Yeah, so...
Or I guess we can ask Gary.
Nice try. Were you like going for the water, or?
No.
Come on up here. Please welcome Gary Larson from the Furnace Works. That's your chair. We're going to kill you later for Gary, for people who don't know him, is a super sophisticated designer of mechanical systems. He and his sons are starting to build out the system that you're seeing above here, and through this panel and after this one, he's definitely a good guy to talk to about how to some of the challenges and opportunities that he's found building this piece, even as designs have changed. Not from any mistake of Gary's, but from design changes and demands of the house design. So
Gary, we were just talking about the process, the collaboration process that you were doing on this project, working with Alex to coordinate, where everything would go through, and designing on the computer and being able to see what will actually be built and how to make that more efficient. How would you say that? How does that contrast with your experience doing other residential
Pretty seamless
project?
Pretty seamless. What they wanted from the beginning of the project is what we're doing now. So not a lot of change orders there, and pretty straightforward once we got into the system.
This is one of the parts of this design are these cathedral ceilings. Steel construction's been around for a long time. There's certainly steel trusses or cords or beams that have open webbings that could be used. And there's a lot of wood beams that are used with open webbings today. But one of the nice parts that Alex was relaying is that just the sheer number of these openings and these runs allow fire sprinklers, lights, obviously the HVAC grills, the return and supply pieces. We designed into the gutter system a trough, not just for the trough of the house and how the whole roof drains, but underneath it. So it's one piece, one highway, where a lot of the electrical and plumbing actually can connect the two sides of the house. So we were able to do that, again, with Alex's help, like, well, that's never going to work, what about this? And it was definitely helpful to talk to someone from BareBONE who could, I mean, I had questions. A guy like Gary had very, very specific questions, like, I need 5 inches round, and he said, and I don't see it, like, please show it to me. And many of those things happen on a residential construction, to your point, right in the field, and someone drills it out, and it's a change order, and it's delayed and everything, but, because of the foam, Gary and his crew changed a few things, and within an hour, like, carved out the styrofoam, put the exterior ducts out the building, we're gonna foam the rest of it when it's finished. So it's actually, even for all of its like rigidness of the steel system, the exterior envelope allows many, many viable ways to accommodate last-minute plumbing, electrical, and mechanical changes.
Gary, can you tell us a little bit? Oh, Alex, you wanted to?
I was just going to say that, you know, being able to come up with the plans for these things early on, as opposed to typical, you know, when a typical construction where you'd be designing this stuff in the field, it's these kinds of structural impacts, like needing to run a big supply line, that are going to then lead to something needing to be modified that's going to cut into your window rough opening. So, for example, you know, we need to modify this beam, we need to expand the beam. Suddenly we lose, you know, you're affecting other elements that are going to impact your ability to order windows ahead of time versus needing to wait till that last minute once everything's dialed in perfectly.
So integrating the mechanical design as part of the process is more efficient, I guess, than if it comes as an afterthought. And I'm sure, Gary, it must happen where you're called and you show up on a project and, all right, well, you know, I probably had some good, you could have had some good input, but it's already too late.
Already built, yes, that's happened a lot. On this one, it was nice because what we seen on the plans is what we got here in reality. So it was easier to map ahead, make sure at each step could fall in lockstep with what the rest of the contractors are doing. So it was pretty straightforward, and it still is pretty straightforward.
Yes, sir.
Is your 3D CAD on site here, or can you do it from the trailer so you don't lose time? In other words, got a problem?
Yes,
Share
yes,
share the model
it's
here
on
at the
iPads
site,
and
and
yeah.
the workers can see what needs to be done, right?
Yeah, so our
You
houses
save a lot of time.
get built off of proprietary assembly plans, which are exactly what you see. It's literally the 3D model printed on pages and label and call outs and everything. We also have a lot of our crews, there will be one guy with access to the 3D model on their iPad or on a computer, and you can literally, it's like walking through a video game scenario. You can look up and see, it's pretty cool.
Because it looks like there was a house there one time, they've got probably a DSL, I mean, you can share it because your computer system is not on site, is it?
No, it's not, but you can download the model
Okay.
onto an iPad.
Got it.
And honestly, I actually didn't believe it. I mean, you can kind of hear the marketing pieces and you can see them streaming through it, you can see websites, and I'm like, is that really going to happen?
Yeah.
But really, I mean, and Howard is nodding his head back there, we were on this site and the steel bolts are going in and Gary's here, and there's a lot of things going on a project meeting, and with a couple of iPads, you can actually move the model around and prove to a subcontractor that is aligned or plowed, and we found many problems that, you know, not all of them, Howard's also not not all of them, but many of the conflicts that go on in any custom home like this. It's not a three-dimensional rendering of like what it's looking like and all those other things. We have the other models for that. This was a very specific piece that the fabricators were using. So we're down to like, this same model is actually what they use to produce the robots to sort of produce the steel. So we knew we were...
And having that one model is key, right? So it's not a Hollywood model trying to make a representation of what it's going to be. What you see there is really what ends up being done. So if you forget a column, it's guaranteed the column will not appear, and the other way around, right? and that's where, that's how it should be, right? It should be a surprise. It should be, you know, let's look at it, it's well done, it's there, and these components of that model literally are sent to the machine that will spit out that exact part. So there's very little human interaction. You have that model, and then so there's less room for error between different models or data loss or things like that, which often is where the error comes from, right? Discrepancies between different models.
And here's when your remodel contractor comes in to open up that bedroom wall, you can look and see exactly what's behind that sheetrock without having to tear it down.
The foundation upon which all that accuracy and that ease of assembly is built is the foundation, and specifically the tie downs. And so when you're pouring the foundation, you're putting the embeds in. you need somebody that pays attention to detail. I still laugh when I think about it. Our GC, you know, we're talking about footings, and said, how close do we have to have them? 3/4 of an inch, you know, an inch, you know, because he's used to wood, right? Yeah, right, exactly. And so it's, no, Alex says 1/8 of an inch, 1/16 of an inch would be better. I said, oh, okay. But when you do that, everything just drops into place. You snap a line, bolt it down, you're done.
And a reason for that, typically, where in traditional construction, it's a normal practice, I guess, is because the material you're working with will anyways not be perfectly straight. So you could be at a 1/16 of an inch, but at the end of the day, you're still going to need to shim and fix and do these things. Versus, in this case, you know, the laser precision of the components. You know, if you're 1/8 of an inch off, it will be 1/8 of an inch off at the other side, right? Not more, not less. And if you're 3/4 of an inch off, it will be the same thing. So what we do, and Alex can elaborate a little bit on the foundation system, because steel will have, it's much more precise than concrete, even if you have a really good concrete subcontractor, right? But we developed a system to be able to adjust to some extent on that front. So maybe Alex, you can elaborate a little bit on that.
Yeah, I would say that every project, when I'm working with somebody who doesn't have a lot of hands-on experience building bone structures, I'll see them over in the corner kind of fussing with a part. Hey Alex, this part, you guys messed up. This part doesn't work. And I go and I look at the part and I read the number and I read the plan. It's the wrong part. So if somebody's saying that something got cut wrong, I pretty much know for a fact that they've misread the part number. I go get the right part and it clicks in perfectly, and that's just how it goes.
We all have that experience with Legos, right? Oh, they put, you know, this one's wrong, this one's wrong. Go back and you realize, you know, you had a wrong part.
So one of the interesting challenges for me as an architect is that typically you hand things off to mechanical subs, but in this place, because there's very limited spaces for, there's no huge ducts for drop lids for a lot of systems that go running. And Gary, I think you should tell these guys what the actual mechanical system that you're using in the high velocity system and why you like it.
So we're using high velocity air, so in this case our ducts could be 2 to 3 times smaller than normal. So this is our main run right here. Normally that's a 6-inch tube, normally that would be a 12 to 14-inch tube. And then our ducts that are going to branch off that are 2 to 3-inch ducts. So duct diameters like that. So the nice thing is, all architecture is designed for plumbers. Plumbers go up to 4, 3-inch. We can follow behind. Anywhere a plumber can go, we can go now with the duct. And that's real incredible. You man put that together with the system. It's super quiet, super efficient on how it cycles the air. It just lends itself to this type of architecture.
Yeah, and the code actually hasn't caught up to some of the technology that Gary is helping build, and some of the heat recovery units that Gary's added over the top of this piece. One of the problems of a building like this, it's so tight on a November night, and everyone's getting ready for Thanksgiving, and everybody's cooking on an induction stovetop, of course, because it's an all-electric house. But the range hood is on full tilt, and what happens is that with a fireplace, or it starts sucking in cold air or air that you don't want from another part of the house, but automatically there's a fan built into Gary's system that actually adds fresh air as this building has to exhaust, whether it's in a shower or in a kitchen or somewhere, some other exhausting capacity. There's actually an automatic system that Gary's designed, so there's more air that's coming in for other parts of the house before it starts sucking in through underside doors or around windows.
And it's a recovery unit, so the heat that we're pulling out, it's being exchanged at about 70% efficiency rate. So we're not pulling in cold air, we're pulling in warm air. We actually exchange the two air. Yeah.
And anytime you're going to have a house with an airtight envelope, that's going to be a requirement. To have adequate makeup air at all times running in the background. in an efficient way.
And that's a good practice. You know, we say we spend quite a bit of time in our homes, and people think, you know, they underestimate the amount of pollution that you might find in your house, and that's why having fresh air ventilation system really control the air quality is key. So if you have a shell that leaks left and right, you're bringing toxic air from areas of your house, such as either it's the garage, in this case it's not connected, and it's an electric car, but
Might be a moldy crawl space filled with rodent droppings,
right,
for 30 years or, you know,
right, exactly, and that air seeps in. So, you know, having control of your air and being able, on a nice day like this, to open up everything. But the minute you close the windows, then it's very easy to just flush the air out and change and control.
Yeah, the air changes per hour are a big deal. So Gary, you've seen this, and Alex, you've seen this too. The plumbing code today is designed really for about 1920, maybe 1930. I mean, we're really about 100 years off, and the capacity in both waste lines and supply lines with current technology is just starting to appear in building codes. We oversize massively water lines in particular, and with Gary's help, it's one of the reasons why people see typical half-inch or inch lines for water supply in old houses, because the water pressure was so low. Because the water pressures and gas pressures and all these other technologies, we're actually reducing the pressures on the outside of the house. It actually makes it for very small lines much more efficient to happen in walls, over ceilings. There's almost no systems other than the drain systems that are in the slab of the building.
Someone earlier had a question about sprinklers.
Oh yeah.
Can you elaborate a little bit on?
Yeah, this is so you can look through the back and in the base of the tower where some of Gary's mechanical system is starting to just pierce outside. One of the next contractors to show up is going to be the fire sprinkler. Of course, every new building in California today is fire sprinkler. And one of the nice parts about this BareBONE system is that we have a trunk line running through the trough. Everything's going to be up in the soffit. But under normal housing conditions, that fire sprinkler contractor will come through, find his own way, drill his own way. It will appear in their own way, and not usually where the owner is expected to see a sprinkler line. So if anything, the BareBONE model was able to let us see all of these pieces overlaid. Most home designs, even when they promise it, don't really force the system. And one of the nice parts about it is that we got to see it that way. What's the biggest sort of miss, do you think, even with BareBONE construction on the MEP installs? You've got all the BareBONE friends around. They're going to love this answer, whatever it is.
biggest miss.
Still. Not anything that BareBONE, it's not a BareBONE mistake, but like what typical contractors still don't account for or overcompensate for. Nothing. It's all perfect. Please
Yeah.
go to the microphone.
Let me think about it.
You can think about it. No, what we see often is some mechanical subs are not necessarily used to working in a really well-built airtight shell. And very often, we'll have a client who will want, a really good system and, put more to make sure that, everything is efficient. But actually, you're making things less efficient because you're oversizing your system for a house that actually will not need much of that heating and cooling. So you're running at a low efficiency rate because you're on, off, right? On, off, and you're not running very efficiently. So having a airtight shell that's well built, and that's where the code is going more and more. So the industry will adapt. but it's definitely not, it's not the norm. And I'd say many subcontractors will kind of go with the rule of thumb of the size of the house and that's it. But there's a difference if you have a house that is at, performs at 7 air changes per hour at 50 Pascal, which is a metric of how much air leaks through the walls, and a house that will be at 0.6 air changes per hour, which is a very pretty much a passive standard. So very different, and that's important. That's some myths that depending if it's a first for a contractor, we will want to point out to make sure that it's properly designed.
We have, I have clients, some real estate developers, some what I would call experienced in the building trade, who will look at a 5,000 square foot house, go, okay, I need, 2 3-ton units, or I need 2 5-ton units. And they'll know what that is and put them on the ceiling. I'm like, no, it's a much more efficient load. You need a 1.5 ton here, and you need a 3-ton here, and I've got my friend Gary who will prove it. And they'll say, no, I want bigger. I don't want to ever be hot on that cold day. I'm like, no, what's going to happen is that, just like Charles described, it's going to go on, it's going to go off, and your temperature cycles in your house are going to go never ever align up, because the system oversized is actually even worse than undersized. Would you agree with that, Gary?
I would totally agree with that. That's why heat calculations, heat loads are so valuable from the computer modeling. I will agree that most HVAC guys will overestimate their equipment by at least 50%.
Yeah.
And in this case, we're doing a variable speed heat pump, so it'll meet the demand. It starts at 1 ton and goes up to 5 ton. So if you only need 1 ton of cooling or heating, it's only going to give you 1 ton of cooling or heating. And it's efficient across the whole barrier, so that kind of solves all the problems right there.
Everything's become so much more efficient that this house, even with 3 structures, machine shop and a garage and a 3,000 square foot house, is actually going to use the same amount of electrical service that a much older house used before. And that's happening all over California, which is why these big service upgrades, and typically when you rebuild or build a new house, like, oh, give me 400 amps, give me 800 amps, but what's happening is that amperage is not needed. The refrigerators today are a fraction of what refrigerators used to need to run efficiently.
And that's the same thing for heat pumps. The heat pump we're putting on in this unit will run about 35 amps. An old unit would run almost 60 amps.
Yeah.
So almost 50% more efficient.
At max.
At max.
35.
So, are there, you guys have questions about the MEP systems? Anything we haven't covered today?
I've got a question, just looking overhead at the ductwork here, Gary. I see sheet metal on the outside, but what is the construction? Is it just a single layer of sheet metal? Or
yeah, that's just sheet metal ducting, then they'll spray foam it for insulation.
Okay.
And then we have soft flex tubing. There are 3-inch soft flex tubing will come off that and go approximately 10 feet and end up out here and out there. So we'll be basically creating a convection pattern for the whole structure. And those are, I have a couple samples back there if you want to see them. But they're coming in from Maryland, should be here Monday or Tuesday, and we'll start stringing those up.
Back in the old days, like 2 years ago or 3 years ago, with flat roofs especially, or mechanical contractors would show up on the site and say, "Hey, where's my 24-inch duct line?" And they're like, "Well, it's not here. You have to go outside and go on the roof." And in the 2019 code, you cannot run ductwork outside the thermal envelope. Not even if you insulate it, even if you, you'd have to literally build a new structure around that ductwork, which would interfere with roofing and all kinds of other issues. So the issues, especially in the 2019 code, is that all of those duct runs have to be within the thermal envelope. So there's not the leakage and the temperature loss, and again, it's shrinking the size of the equipment that contractors like Gary would need.
And even traditionally built houses where all of your ductwork is in your attic, that's unventilated, or it's ventilated, but it's unconditioned space. So your air conditioning ducts are running in that baking hot attic. In the winter, it's that freezing cold attic. Here, every one of these ducts is going to be completely encased in similar foam that's on the outside. It's going to be open cell foam, so it's a little bit less dense, but nonetheless, you're really maximizing every single inch that those ducts are running, so that they're not losing any of the heat or cool.
Did you look at gray water separation?
We did. There just wasn't the load in with a sort of 3 people living here to justify the cost. The water use and reuse for, you know, what I would call a 10-unit affordable workforce housing with a lot of kids and sort of a bigger population is where I think the gray water separation parts are added. We do have a catchment basin for rainwater for the what I would call kind of the extension of maybe a month into the summer for some water. We looked into it, but at a certain point, there's just not the amount of water. The laundry and the dishwashing and all those other pieces were just not big enough to really justify the cost. So,
Okay. So with that, I think we're going to wrap it up. I'd like to thank Gary, Alex, and Brendan for joining us. And thank you all for being here, especially those of you who were here for all 4 panels.
yes, yeah, we should give you guys a special prize.
Thank you.